Okay, so we're just going to go over just a couple examples of how to make a table and then graph an exponential equation. So in this case, y equals 9 times 1/3 to the x. So first thing you want to do is just make a table. We'd like to go from normally negative 3 to 3. So we know the x values are inputs, the y values are outputs. So we can just take these x values, each one, put them in for x, find a y to get out. And then we'll have our y values, we'll have our pairs that we can graph. So y equals 9 times 1/3 to the negative 3. All I did was replace this x with negative 3. That's my first input. So 1/3 to the negative 3. We know with a negative exponent, that's going to be the reciprocal of this. What's that mean? That means we're going to take it and flip it over. So instead of being 1/3, we'll flip that over. It'll be 3 over 1. It'll just be 3. So 3 to the third. 3 to the third is just 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 is 27. So that's just this part, right? 1/3 to the negative 3 is 27, so we have to do 27 times 9. So y equals 9 times 27, which is 243. So that's going to go here. That's one of our points, 243. Not going to be on the graph, it looks like. So the next one's going to be the same thing, but with negative 2 times 1/3 to the negative 2. We know that 1/3 to the negative 2 will be the reciprocal. That's just going to be 3 to the positive 2. So that'll be 9. 3 times 3 is 9. We'll plug that back in here. Y equals 9 times 9, and that is 81. More quickly, same process with the negative 1. That'll be the reciprocal. So 3 over 1 to the 1. 3 to the first is just 3. So y equals 9 times 3, which is 27. You're getting the hang of this, so we're going to move a little quicker here. We know when we plug in 0, anything to the 0th power is just 1. So 9 times 1 will be 9. Then we'll have 1/3 to the first. So that'll give us 9 times 1/3. 1/3 to the first is just itself. When we're multiplying fractions like these, remember we can multiply straight across. That's 9 over 3. It's really like dividing by 3 here. 9 divided by 3 is just 3. That'll be our next. Then when x is 2, we'll get 1/3 squared. 1/3 squared is 1/9. So 9 times 1/9 is just 1. And then 1/3 cubed, we're going to be dividing by 3 again. So that's going to be 1/3. We have all of our points here, and all we got to do is plot them. Let's use purple. So we're just going to go through. When x is negative 3, we're going to be at 243. That is way off the graph. When x is negative 2, we're going to be at 81. That's off the graph too. When x is negative 1, we'll be at 27. That's off the graph too. Okay, when x is 0, y is 9. When x is 1, y is 3. When x is 2, y is 1. When x is 3, y is 1/3. So how do I put 1/3 on? It's between 0 and 1. It's about 1/3 of the way up. So I'll put it here-ish. Okay, something we should know here. It's going to go up to 27. So I'm going to go ahead and take this as a curve up to 27-ish, right? Because it's not on our graph. So I'm just going to point it in that direction. What's going to go on as we go this way? Well, we know since we're dividing by 1/3 each time, we're multiplying by 1/3. We're dividing by 3 each time. So divide, divide, divide. We're going to break it up into a whole bunch of different parts, but it's never going to be 0. It's never going to be negative. It's just going to get really, really small, really, really small as we go. So we know that there's an asymptote there at y equals 0. So what are we going to do? We're going to do a dotted line across 0 to show that that's an asymptote, to say it's going to approach this for forever. It's never going to reach it, but that's just where it's headed. So we're going to kind of continue that line along that dotted line and put a little arrow and say that's our asymptote. So what you got to do from -3 to 3, get some values out, plot the ones that you know, take the curve like this. We know that since b is between 0 and 1, that this is going to be a decreasing curve. It's going to be a decreasing curve because we're multiplying by 1/3. That's the same as dividing each time. So as we go, we're dividing by 3 each time here. And as we go this way, we're multiplying by 3. That's why it ends up heading off this way, but going down towards the asymptote as we move right. We also know that a, in this case, y equals a times b to the x. A will be your y-intercept, and you can see that's what happened here. A 9 is the y-intercept here. We could have known that from the very beginning. Just something to notice. So let's do another one here. Y equals 1/2 times 4 to the x. This time b is greater than 1, so we know this should be an increasing graph. It should go like this. We also should know that the y-intercept is going to be 1/2. But let's go ahead and do the table. So 1/2 times 4 to the x. If we plug in -3 here for x, -4 or 4 to the -3. We're going to take the reciprocal of this guy, so flip him over. He's now 1/4 to the 3rd. Well, 1/4 to the 3rd. Four times 4 is 16, and 16 times 4 is 64, so that's 1/64th. And then we're going to go back up here and multiply times 1/2, right? So y equals 1/2 times 1/64th, which is 1/128th. So there we are. Okay, so then we'll replace x again with -2. That'll be 1/4 squared, which is just 1/16th. Then we'll have to multiply by 1/2. That's 1/32nd, and there we go. 1/32nd. I messed this up. That should be 1/128th. So 1/128th, 1/32nd. Then we have to do the negative first, so y equals 1/2 times 1/4, because it's going to flip it over, so that's going to be 1/8. When this is 0, 4 to the 0th is just 1, so 1 times 1/2 is 1/2. And then times 4 to the 1st, so 4 to the 1st is just 4. 4 times 1/2 is 2. 4 squared is 16. 16 times 1/2 is 8. 4 cubed is 64. 64 times 1/2 is 32. So let's plot those. -3, 1/128th. That is a tiny, tiny number. Let's just guess it, kind of down there. 1/132nd. We're not even going to notice a difference on this because they're so small. 1/8, similar. And then we know the y-intercept is 1/2. We need that from the beginning since it was there. So this should be 1/2 of the way up to 1. And then on 1, it should be 2. 2, we're going to 8. And then 3, we're going to 32. So I don't know where that is. So I'm just going to take this curve and head it up towards 32. All right, now this way we know, again, is going to be an asymptote because as we're going this way, we're multiplying by 4, but as we're going this way, we're dividing by 4. So divide, 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 will get smaller, 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 but never be 0. So we've got a dotted line, that's an asymptote right there. And we're just going to take this towards it. And again, we know that this should be the y-intercept, and it should be an increasing graph since b is bigger than 1. So there we go. We just take the equation from -3 to 3. We'll get some values out. Then we know what to plot. We know that in this case, whenever it's of the form y equals a times b to the x, that we're going to have an asymptote here at y equals 0. And so we'll make a dotted line there, and then we'll graph. Nice little curve there.